So hi everyone and welcome. As Chris mentioned, I'm Margot Shadell. I'm a developer advocate here at InfluxData. And today we're going to be covering, as part of the Getting Started series, we'll be talking about an introduction to Kapacitor and its domain service language TickScript. So let's take a look at the agenda for today on what we'll be covering. So we'll go through some of the basic concepts around the Influx platform, specifically around Kapacitor. So we'll talk about what Kapacitor is, how we can install Kapacitor. We'll try to understand TickScript, especially with regards to its quoting rules, which can get a little bit finicky. We'll talk about stream tasks and batch tasks and the differences between those. We'll talk a little bit about how to trigger alerts. We'll try to understand Kapacitor as a downsampling engine, as an alternative to using continuous queries on InfluxDB. So before we jump right in specifically into Kapacitor, I just wanted to give a brief overview about the InfluxData platform and talk a little bit about what time series data is. So for anyone who's new to it, time series data is a series of data points that are indexed or listed or graphed in time order. So time is a very important point here. So all of the data that's coming into this database will always have a timestamp. And then specifically InfluxDB that you can see on the diagram there, it is a time series database. It is a purpose-built time series database that's optimized for high volume ingestion and output of time series data. And the reason why InfluxData built this is to kind of make things easier when you're looking at time series data. You're usually getting it in high volume, and you usually want to be able to query it in real time and observe it in real time. So you need something that's really lightweight. And InfluxDB can do that for you. So it really conserves disk space. It can compile down to a single binary, which is really lightweight. Like it can run on Raspberry Pis, for example. And it has built-in features like its retention policies that kind of auto-expire the data as it becomes irrelevant. And then the other projects that were built around InfluxDB, Telegraph, which is a data collection agent, and then Chronograph, which is our visualization tool to be able to build out dashboards and view the data in real time. And then the third project, which we'll be talking about today, Kapacitor, that's our real-time streaming data processing engine, which can handle a lot of those really important features, like being able to downsample your data as it becomes, less important over time, and then being able to handle alerting capabilities, and kind of relieving some of the pressure of the features that are already built into InfluxDB. And then lastly, just to consider like real-world use cases for InfluxDB and the InfluxData platform. Generally, when you would want to use a time series database are for things like storing IoT, which is Internet of Things, IoT sensor data. We see a lot of people using this in the DevOps space with monitoring of platforms or server infrastructure, and then also in real-time analytics. So those are just three of the many use cases for the InfluxData platform. You can also do things like use it for application and performance metrics. And then lastly, you can just see here that our platform, there's an open source core. So you can actually run Telegraph, InfluxDB, Chronograph, Kapacitor all for free. And then just where it becomes a commercial offering is if you need things like high availability, clustering, security. And for those, you could either use the cloud solution or the enterprise solution. All right, let's jump into some of the key Kapacitor capabilities. So I briefly mentioned this a little bit already, but the Kapacitor project, it helps to kind of relieve some of the pressure from InfluxDB, and you can so you can use it together with Influx to handle things like alerting. So if you want to like monitor your data and trigger alerts if data hits a certain threshold or something like that, you can then, once that alert hits or triggers, you can have it sent to a number of different platforms, like such as you can have Slack messages sent it to your email, through logging, kind of however you want to receive that message. And then the other capabilities is in processing ETL jobs. And just for anyone who's not familiar, ETL, which are 3 database functions combined into one tool, just to pull the data out of a database and place it in another database. So extracting is the process of reading that data. Transformation occurs if you're like combining the data with other data or something like that, kind of manipulating it. And then load is the process of writing the data into another target database. And this becomes really important with things like if you want to downsample your data over time, you want to kind of pull it out of InfluxDB and then kind of roll it up to a lesser granularity because it's probably not as important to keep that very high granularity data for long periods of time. And then you can write it back into InfluxDB or to another database. So it helps to handle some of the really key features that you'll see happening with time series data. All right, let's look at Kapacitor in a little bit more depth. So as I mentioned, it's a real-time streaming data processing engine. So it's a native data processing engine. It can handle both stream and batch data from InfluxDB. And we'll actually cover this in a little bit more detail in a minute. But you kind of have a choice between the way in which you want to like pull your data out and downsample it or transform it. You can plug in custom logic and user-defined functions to do things like if you want to process alerts, so any of that like triggering alerts and then having those triggered dependent on dynamic thresholds, so they're not always the same. You can also do things like match metrics for patterns, compute statistical anomalies, and you can perform specific actions based on these alert capabilities like dynamic load rebalancing. So it really has like a lot of kind of self-healing capabilities with it. As I said before, you can definitely downsample data with Kapacitor, which is really important for time series data, especially with like the high volume that you're going to get with ingesting that into InfluxDB. And then specifically with like the alert capabilities, it can integrate with other platforms such as HipChat, OpsGenie, Alerta, Sensu, PagerDuty, Slack, and many more. So you can kind of integrate that with other platforms if you need to trigger alerts and then kind of do some incident response and incident management through that. All right, so in terms of installing and starting Kapacitor, it's pretty much the same as installing and starting the other parts of the platform. So all of the different builds are available at this link here, portal.influxdata.com/downloads. So this specific example that I've shown here, this is the installation instructions for Ubuntu and Debian OS. But if you have a different OS, like if you're building or if you're trying to install it on a Mac, or if you want to pull a Docker image, you can do that. There's also Windows and Linux versions. All of that's available in detail from that link. So you can very easily navigate to that link, choose look for the proper OS that you want to install it on, or look for the I think if you want to install a Docker image, you can just start pulling the Docker image. But it's very easy to get installed and up and running. when I first started with InfluxData, I pretty much had everything installed and up and running like in less than 30 minutes. So it's a very quick process to kind of get things moving. Okay, so defining tasks. So in the next couple of slides, we're going to be learning how to write our own tasks in Kapacitor using its domain server language. It's called Script, and that's the scripting language that Kapacitor uses. But before we dive into actually writing a script or like looking at examples of script, I mentioned before that you can run both batch tasks and stream tasks in Kapacitor. And I want to cover a little bit more on what those are. So let's start with batch tasks. To kind of explain what a batch is a collection of data points, and they've been grouped together within a specific time interval. So you can think of this as like a window of data or an interval of data. And then what happens when you run a batch Kapacitor task is that Kapacitor is going to query InfluxDB periodically, which is great because you end up not having to buffer much of your data in RAM. So you don't have to like store it all in memory. And we see that this is a great choice for when you need to perform things like if you need to perform aggregate functions on your data. So if you took a window of data and you need to find like the mean or the max or the min of that set interval, running a batch task is a great way to do it. Also in cases where if you want to trigger alerting or trigger alerts, sorry, if it doesn't need to trigger on every single data point, such as in the case where state changes don't happen that often, running a batch task is great because you can kind of avoid being inundated with all those alerts. Another example for a batch task use case is downsampling your data. So if you want to take a large collection of data points and then retain only the most significant data. So this kind of ties into what I mentioned before with performing aggregate functions on a set interval of data. So you can kind of maintain like an overview, like a snapshot of what's been happening in your data, but you don't need to keep it, you don't need to keep it to the nanosecond or something. Another instance is where batch tasks are great if you don't mind a little bit of extra latency. So as long as latency, like a little bit of latency won't severely impact your operation, batch tasks are a great way to go. And then any case where like there's a super high throughput InfluxDB instance, because Kapacitor cannot process the data as quickly as it can be written to InfluxDB. But this case kind of tends to happen more with like Influx enterprise clusters. The one thing I will say about batch tasks though is that they do place a little bit of an additional query load on InfluxDB because, and we'll look at this in a bit, because when you're running a batch task, it's going to have to query InfluxDB for the data. All right, let's look at the other side. Let's look at stream tasks. So stream tasks are a little bit different. With a stream task, what's happening is that it creates a subscription to InfluxDB so that every data point that's written to InfluxDB is going to also be written to Kapacitor. Now, because of this, stream tasks are going to use a higher percentage of available memory. So how much memory that is available is going to be a key factor to like take into consideration. However, there are some use cases where you definitely want to use a stream task. So for example, if you want to run some kind of function or transformation, if you want to manipulate a single, like each individual data point in real time, even though you could technically run this as a batch task, there is like some of the latency issues to consider. So if you need like if you have a case where you need like the lowest possible latency, and that's really paramount to the operation, then running a stream task is going to ensure like the least possible delay. And then another case is when InfluxDB, if InfluxDB, if the time series database is handling a high volume query load, if you want to kind of alleviate some of that query pressure from InfluxDB, you can switch to a stream task. But then, of course, this does place a little bit of an additional write load on Kapacitor instead. So it's, yeah, you kind of have to kind of weigh up the two and see which one will be a better fit. And then one last thing to note is that stream tasks actually understand time by the data's timestamps. So there's not going to be any race conditions for when exactly a given point would make it into a window or not. So like if you look at batch tasks, on the other hand, it is possible technically for a data point to arrive a little bit late and then be left out of its relevant window. It's pretty unlikely, but it could technically happen. And then the other thing that we'll see when we start looking at the tick script examples is that if you're writing a stream task, it could end up being slightly easier defining a task using only Kapacitor's tick script without having to actually like work on writing queries for InfluxDB as well. So like with batch tasks, you've got to be knowledgeable of Kapacitor's tick script, and then also with InfluxQL, with InfluxDB's query language. But ultimately, I think batch tasks are probably usually the way to go because they use way less memory. So that's definitely something to consider when you're considering whether to choose a batch task or a stream task. All right, now that we have spoken a little bit about batch tasks versus stream tasks, let's actually look at tick script, which is Kapacitor's DSL. So what is tick script? So Kapacitor uses a domain-specific language named tick script in order to define these tasks, batch or stream, involving the extraction, transformation, and loading of data, and involving the tracking of arbitrary changes and detection of events within data. So when you're actually trying it out and using tick script, tick script is used in .tick files to define pipelines for processing data. So it's a chain invocation language. So it's going, so this, you can see that pipe there that chains together different nodes. And just to cover really briefly what a node is, the fundamental type is the node, and a node can have properties and chaining methods. And a new node can be created from a parent or sibling node using one of those chaining methods. And for each node type, the signature of this method will be the same regardless of the parent or sibling node type. So the common node types are batch, query, stream, from, eval, and alert. But there's a lot more than that. So definitely, if you have a chance to go through the tick script, the Kapacitor documentation, there's a whole glossary of terms on that. And then the top level nodes, which I've already discussed, stream and batch, they define the processing type of the task. And those don't take any arguments, they just are declared. And then, so you see under the pipe, you see the period, the dot, that refers to specific attributes on a node. And then the second point here, variables refer to values. So strings, integers, floats, durations, and pipelines. And one thing to remember is a script has a flat scope. And then we have different methods. So you can have a property method, which that modifies the internal properties of a node and returns a reference to the same node. So that's what I was talking about with the dot there, refers to specific attributes on a node. And then the chaining method creates a new child node and returns a reference to it, and that uses the pipe. On the right-hand side here, you can see an example of a tick script. Okay, the tick script syntax quoting rules. So this is really important to remember. So specifically double quotes, when you're using double quotes, this is referencing data in a lambda expression. And single quotes are referencing a literal string value. So we use the lambda expressions to define transformations on data points and also to define Boolean conditions that can act as filters. And so these lambda expressions wrap mathematical operations, Boolean operations, excuse me, internal function calls, or it could be a combination of all three. So if anyone's familiar with like InfluxQL, this is like very similar to the InfluxQL where clause, but it has a couple different syntax points. So if you take a look at like the example here on the right, all field or tag identifiers, they must be double quoted. So you can see like, you can see the double quotes around is underscore up, and you can see the double quotes around my underscore field. And then comparison operators for equality are either like a double equals or a single equals. And then all lambda expressions would begin with lambda as the keyword. So you can see that defined there, where it's, you can see the pipe where, and then lambda colon, and then it gives you the expression that you're evaluating. So just to remember, double quotes reference data in lambda expressions, and single quotes represent literal string values. Okay, so we're gonna start looking at a few examples of a stream tick script. So what you can see here, this is a tick script named cpu.tick. So the tick script files always end in that .tick syntax. And we've defined the type of task we want to run, which is a stream task. So that's the first node, stream. And then you can see we're chaining the following methods. So you'll see the pipe from. And specifically, we're going to be looking at the measurement CPU, the CPU measurement. And then the following method that's piped from that is to log all of that data. So what this stream tick script is doing, it's just logging all the data from the measurement CPU. Okay, so the left side here, this is the capacitor tick script. So this is the same example as what we just saw on the previous slide. This is like what the actual tick script would look like. And then the right-hand side there, this is how you would write the tick script if you were going to write it in your terminal. So that's why you can see the little $sign. So you would just, you would call capacitor defines CPU, you're naming your tick script file, you're naming the type of task, and then you also have to reference which database you'll be drawing the data from. Okay, so to move forward with that, the left side you can see here that this is how you are how you're composing your capacitor tick script in the terminal. And then on the right side is kind of the result. It's showing the result of executing that task. All right, let's take a look at a little bit more interesting, a more complex tick script. So this is still kind of building from the tick script example we looked at before. We're still looking at a stream task. We're still looking specifically at the measurement CPU. But now we've added in this pipe window method. So now what we're doing is we're creating 5-minute windows of data, so like 5-minute intervals of data that are going to be emitted every 1 minute. And then from that data, another method is to compute the mean, so to compute the average of the field, so specifically the field within that measurement, just the usage underscore user. And then once it computes the mean of that 5-minute window of data, we're going to log the result. So you can see how you're just chaining different methods as you kind of move forward in the pipeline. Okay, so to build on that a little bit more, still a stream task. We're still looking at measurement CPU. Now we've added another method. We've added the pipe where, and we've added in a lambda expression. So specifically to evaluate where CPU is equivalent to CPU total. So we're going to be filtering on the tag CPU. So we'll only be looking at CPU total or any data with CPU total. And then still from there, we'll be creating those 5-minute windows of data that are emitted every 1 minute, and then also calculating the mean of the usage user, and then logging the results of all that data. All right, so here you can see, this is still the same example from before, but now we're adding the alerting capabilities. So it's still a stream task from CPU measurement. It's still filtering by that CPU total tag. Still creating those windows of data and calculating the usage user average. Excuse me. But then now what we're also adding is this alert method where we've added another lambda expression where if that data, if that mean that comes back of usage user goes over that threshold, goes over 80, then anytime that happens, you'll be sending an alert to both, in this case, you've dictated what the message is going to say, and then you've sent it to via Slack and then also via email. So you can actually send it to multiple places if you need to. All right, kind of moving towards the other side of it, let's look at a batch tick script. So this is, as I said before, going to be querying the database rather than the stream task where like it creates the subscription that every data point is also written to Kapacitor. So here you can notice that you actually have to use InfluxQL within that tick script. So you'll see the batch node, and then it's always followed by a query method, so the pipe query. And then inside of that, inside of those parentheses, you can see that's InfluxQL. So you're selecting the usage user, the average of usage user, relabeling it as mean usage user, and then you're dictating from which database do you want to grab that. So you're grabbing it from the default telegraph, retention policy, autogen, and specifically the CPU measurement. So that in and of itself is an InfluxQL query, if anyone's familiar with that. And then you're querying all of this data in 5-minute windows every 1 minute, and then after that you're logging the result. So this is still trying to achieve what the other stream task example was trying to achieve. It's just that it's in a different way. Okay, so on the left side here, you can see that this is the same example we just looked at with this is the actual tick script showing the batch task, querying the database, dividing it into 5-minute windows, and then logging it every minute. And then on the right-hand side is how you would have defined this task in your terminal, which is very similar to the way that you define it in define a stream task in the terminal. Okay, so here you can see a little bit more complex of a batch tick script. So the top area is the same. We're still running a batch task. We're querying our telegraph database, trying to find the mean of usage user from the measurement CPU, dividing that into 5-minute windows. And then below that, you'll see instead of logging, we're using the alert method. So this is the same as in the stream task, if any of you can remember that. It's only going to alert on that data once that lambda expression evaluates to the usage user above 80, or the mean usage user above 80. And then if that were to evaluate to true, then it will be messaging both Slack and email. So still using the same method there to do that. All right, so just to reiterate, because this is a lot of information, the differences between batch and stream. So we did just look at the batch tasks examples, and you saw in that example that when you run a batch task, you have to query InfluxDB. So you query InfluxDB periodically, and this is great because it doesn't put a lot of, you don't have to use a lot of memory. It doesn't have to buffer as much of the data in RAM. However, this is placing an additional query load on InfluxDB because of the fact that when you're running that tick script, you are technically querying the database, right? You still have to query it for that data. So even though it's not putting as much in memory, it is also putting a little bit of pressure on Influx. Whereas with the stream tasks, which we saw as the first example before, stream tasks create that subscription where every data point that's written to InfluxDB is also written to Kapacitor. So all those writes are mirrored. And then because of that, it has to buffer all of that data in RAM. So you'll be putting a little bit more pressure on memory, less pressure in terms of querying the database, but more stuff in memory. And then it's also placing a slightly additional write load on Kapacitor. But you're getting that really extremely low latency, like the lowest possible latency you're getting with stream tasks. Whereas batch tasks are great if you want to do roll-ups of the data, like if you want to downsample it, or if you need to perform like aggregate functions. So for example, finding like the mean of the usage user on like a 5-minute window, like that's great in a batch task. I guess I should stop here real quick and ask if anybody has any questions. Oh, I can't see the.
Yeah, there's a ton of questions. There's a lot of questions, Margot. So maybe okay. Let's just continue going. I think.
Okay.
Yeah, because there's a lot, and
yeah, that we still have quite a number of
slides
left.
Yeah.
Okay. Well, yeah, I'll try to go through this a little faster. Okay, so let's talk a little bit more about Kapacitor for downsampling purposes. So as I said before, with time series data, you've got, you're getting it in very high volume. So after it kind of becomes no longer relevant, you need to downsample that data. You need to cut it down and just retain like more of an overview snapshot of it. So there's actually a great blog by another developer advocate at InfluxData, Katie Farmer. She actually talks a little bit about using continuous queries, which continuous queries, if you write them, they also can downsample the data directly on InfluxDB. She talks about like kind of the differences between using continuous queries and using Kapacitor to downsample data. So I would highly recommend, if you have a chance, to take a look at that blog. It helps clear up a lot of, like it goes through like the pros and cons of using each type. So definitely check that out if you're able to. But just to explain downsampling a little bit more, it's the process of reducing a sequence of points. So you would take like a window of data, and then you would compress that to a single data point. And usually the way you would be doing that is you'd perform some kind of function on the data, like calculating the average or taking the max or the min of that window of data for a particular series. And so it just allows you to cut down like that high volume of data into like a smaller, it's a little bit more compressed. Okay. Okay, so why should you downsample? So as I was saying, time series data is generally coming in high volume, and then you can, because of this, like storage concerns could quickly arise. So we downsample data so that we can have faster queries in future, and then over time, you don't want to store, like you might not want to store data from a month ago in such high granularity. You still want to retain like kind of a snapshot, an overview of that data, but you don't need to keep all of those data points to the nanosecond. Like you could store it in 5-minute windows or something. So you'll just, you'll end up like kind of, you'll still keep a good idea of what happened during that time, but you'll significantly cut down on the storage concerns for that. Okay, so using Kapacitor to downsample your data. So as I said before, you could technically use continuous queries on InfluxDB to downsample your data, but if you don't want to have that additional query load, considering downsampling using a Kapacitor script can definitely help to kind of offload that pressure. So you can like offload some of those computations to a separate host. And so all you would have to do is create a tick script, create a task that would aggregate your data based on like how like large your time intervals that you want for it are. And so you can choose to either downsample it using a stream task or a batch task, depending on what your particular use case is. We most often see people using batch tasks for downsampling, just because, as I said before, stream tasks put a lot of stress, or like they have to buffer all that data in RAM, so it puts a bit more stress on the memory usage. And then after you've rolled up that data, after you've downsampled it, you can actually write that data back into InfluxDB, and it would usually be into like a different database, or it would be under a different retention policy, because you would probably want to keep that data for a bit longer. Okay, so here you can see an example of a batch task, a tick script, of downsampling the data into 5-minute windows. So as we looked at before, when you run a batch task, you must immediately query the database. So you run that InfluxQL statement, select mean of usage user. You're grabbing it from the Telegraph database, specifically the CPU measurement. And you're taking it in 5-minute intervals, 5-minute windows. And then after you've rolled that data up, you're putting it back into InfluxDB, and you specify that you want to put it back into the Telegraph database. And this time you're labeling it under a different retention policy, just to make sure that that data doesn't get dropped or expired under the original retention policy. And then adding a tag to it, and which describes where it's coming from. Okay, I think we're actually almost at the end. So just to go over it one last time, since there was a lot of information here. Batch tasks versus stream tasks in Kapacitor. So batch tasks, as we just saw in that downsampling tick script, they have to query InfluxDB periodically. So like that one was querying InfluxDB every minute, which could put additional pressure on InfluxDB. But the advantage is that you're not having to buffer much data in memory. It's using limited memory. And we see a lot of people using batch tasks specifically with downsampling because you're usually trying to perform an aggregate function on your data. So when you're taking if you're taking like a 5-minute window of data and you just want to grab the average of that or the maximum of that, running a batch task for that is a great way to achieve that. On the other side of that, stream tasks. So as I mentioned, stream tasks, the Kapacitor creates the subscription to InfluxDB so that every data point that's being written into InfluxDB is also having to be written to Kapacitor. And so because of this, it's buffering all that data in RAM, so it's just using up a lot more memory. So that's definitely something you need to consider in terms of like what resources are available to you. But if you need to do any type of transformation on individual data points, stream tasks are a great way to do that. And they'll also, you can get the lowest possible latency. So anytime where like latency is an issue, stream tasks are a good way to go because they ensure the least possible delay. And then additionally with stream tasks, like you don't have to be really familiar with InfluxQL. When we looked at that batch tick script, you saw that when you run the batch, you have to immediately query InfluxDB and you have to have an InfluxQL statement for that. So you have to become familiar with both. Not that they're necessarily super difficult, but like InfluxQL is very SQL-like. So if you have any experience with that, it's definitely doable. But stream tasks do allow you to avoid having to write those query statements. But then it does put a little bit of additional load on Kapacitor. So I would say generally situations where you need the lowest possible latency, and that's really integral to your operation, stream tasks in Kapacitor are going to be the way to go. If you're not as worried about that for your use case, then batch tasks are great because it's using up way less memory. It can handle that downsampling really, really well. And just make sure that it's not putting like too much additional query load on InfluxDB. Okay, I think that's it. I think I've covered everything for today. Let's jump back into that chat and we can cover those questions.
Yeah, let's go through those. And even though the questions might have been answered, Margot, let's read the questions and the answers for those that might have missed it. And once we go through that, then there's some questions in the Q&A as well.
Oh, so am I looking at the Q&A first or the?
No, go to the chat first.
Oh, the chat. Okay,
yeah.
I just saw that. Okay. Whoa. Can we get the presentation slides? Yes, I guess.
Yeah, all the slides are posted into SlideShare, so yeah, those are available. And then the recordings will be in the same URL that you got your that you registered at, and an automated email will be sent to you tomorrow. But if you're anxious to listen to this today, after I do a quick edit, just follow that URL. Or I also posted the same URL in our chat panel as well.
Okay. Can I install all three chronograph, InfluxDB, Kapacitor on the same server? If yes, do I need to increase the hardware specification? Yes, so you can install all four actually on the same server. You can install chronograph, Influx, Kapacitor, and telegraph if you want it on the same one. The platform itself is really lightweight. Like one of my coworkers is running the entire tick stack on a Pine 64. Another coworker has run them on Raspberry Pis. So you can definitely install all three together if you want, or all four together if you want. In terms of hardware specifications, there's actually a really there's a really great page in the documentation that kind of goes through the guidelines for that, with like specific numbers and everything. Like I can't remember everything off the top of my head, but I can find that link and then put it in here.
Yeah, and then I think it also, the other thing to keep in mind, it's also going to depend on the shape of your data. How much are you collecting? You know, how many different time series are you collecting? How many tags are getting applied? What's the precision of the data? What's your retention policy look like? Because, you know, are you, you know, is it going to take up a bunch of storage? We do compaction, and as Margot mentioned, but it's all going to really depend on what you're also, you know, doing with it. I think besides that link that Margot is looking for right now, the other place to just get a sense, well, one, there's been some really kind attendees today that have given some of their experiences in the chat panel, so you can definitely look at what they've done. But one of the things that we do is we do these competitive benchmarks, and those are posted on the website, and I'll post the links in there. What you may want to just take a look at is we actually describe the data set that we are using in the benchmarks, and then we run a couple of tests on it. We run a test for ingest rate, a test for query rate, and then also for storage. So that'll just give you a pretty good idea of what the load looks like. Just ignore the competitive part, but just look at, you know, what we're kind of describing in there. We get this question quite a bit, and we are trying to figure out how best to be able to allow you to make that determination without having to do a ton of testing yourself. And I'm hoping that we can come up with something. It's been an internal debate for quite some time, but I would say look at the docs, and then I will get that link to the competitive stuff, because I think that also can give you a really good idea of what that looks like. So let me find it. Here it is.
You're talking about the benchmarks?
Yeah, because in the benchmarks, what we do is we describe a typical DevOps use case. I'm actually going to be updating these with more of an IoT kind of a use case, and we talk about, you know, what kinds of measurements we're taking, at what precision, how many tags we're adding to these things, etc. So that, and then we just test for those three things that I mentioned: query, ingest, and also storage. So you can get a sense of, you know, how well this thing performs. So I just put the link in there.
Oh, okay. Yeah, I also put the link for the hardware sizing guidelines in there.
And here we go. There's another person from, I guess it's Mr. NJ. So he says that he literally created 150 series on 32 gig machine. It was running just fine. Yeah, so, you know, of course, but be careful when we talk about the number of series, because it can also be, there's a lot also behind that. Like I said, how many tags you're using, what's the precision at, but that's still a really impressive number.
Okay, great. So it looks like these are similar answers. Okay, what I heard is I can use Kapacitor to do aggregation and store that in InfluxDB. When should we do this rather than using a continuous query to do the aggregation? Is a continuous query costlier to do the same work? So when I mentioned this earlier, I have to find that link to the blog, but there's a really great blog that covers using continuous queries versus using Kapacitor to run aggregation functions or downsampling. Generally, I believe that if you are running a significant number of continuous queries to kind of help offload that pressure, if you can move some of that into Kapacitor, it can definitely remove some of the pressure from InfluxDB. So I think it also depends on like how like elaborate or how elaborate those computations are going to be. If you're doing like really elaborate computations, then like you probably want to downsample through Kapacitor instead of trying to run a really complex continuous query in InfluxDB. But there's a really great blog on that I can try to find. Nope. CQs versus capacitor. Here it is. So let me throw that link in there. Katie Farmer does a really great job of explaining the differences between the two, and then also like kind of when to use each, when to use which one. And then the other question was, can we send a critical alert to, say, PagerDuty, and then a warn alert to Slack and an info to emails in the same tick script?
So I actually, that was also
about that.
So I actually answered that question in the Q&A as well. So yes, you can. So there's
Oh, okay.
so there's two ways that you can do it. One is you can create 3 different scripts, which is not what you asked, but that's like the easy way, right? Because then you just basically, defining, the same data set and the same thresholds, and then you just send it to each of the different tools that you want to use. Alternatively, we talked a little bit about handlers. That's exactly one of the reasons that you want to use a handler, so that you can then be able to set, the different kinds of thresholds for the 3 of the tools, and then send a warn and a cred and whatever else you want to the 3 different tools. So that's precisely the reason for the handler. So that's a really good question. So thank you.
Okay. It would be nice to go through some of the code line by line. I guess I'll have to do some more examples of that next time.
Well, it's a good blog for you to write.
Yeah.
Follow up.
For sure. Okay, so for data center performance, which one is good, stream or batch data? I guess I'm a little unsure what you mean by data center performance. That, like, is there like a specific circumstance that we're speaking of? It just seems a little general.
Okay, let's put that on hold and wait for an answer.
So specifically for CPU metrics, which one is good, stream or batch? So that's kind of, I guess it's not so much just like if you're covering CPU metrics, whether to use a stream or a batch task. You could conceivably do both. As I said before, when you want to use a stream task is usually when you need to perform an operation that requires the lowest possible latency. So if latency is ever an issue, then that's definitely when you want to use stream tasks. Otherwise, generally it's a lot better to use batch tasks, because it's just it's not gonna put that pressure and use up all your memory. Also, with anything where you want to do those functions, like those finding the mean or the max or the min, like any of those aggregate functions, usually batch tasks are the way to go for that. I don't know if that answers the question, but slides will be posted. Okay. So the blog site address I just put into the chat. Okay, so if I'm using a batch, I am trying to get my head around what the benefit would be of using Kapacitor versus just writing a script in Python or some other language and querying the database. That's actually a really good question. I hadn't even really thought of writing a script in some other language. I think that what Kapacitor, what this tick script offers, or if you want to run continuous queries in InfluxDB, like it has all of those features and that functionality built in specifically for time series data that I'm not absolutely sure that kind of functionality or features would be available with another language. So I'm sure it's certainly possible that you could write a script in another language, but I think depending on the type of computations you're trying to perform and like how you're trying to downsample that data or what you're trying to do to the data, Kapacitor, tick script, and then InfluxQL come with a lot of functionality that's already written into it, so you don't have to spend time writing it yourself. So that's probably the key advantage there. But I am actually not super familiar with writing scripts in other languages for InfluxDB at least. Downsampling, will it cut information from my database? What if I need the information for later use? Can I restore it? So downsampling is not actually what cuts the information from InfluxDB technically. That actually comes with our retention policy feature. So when you create a database and when you start inputting data into that database in InfluxDB, you have to have a retention policy for it, which will define when data will auto expire, so when it will be dropped from the database. And so usually what people do is as data is coming into InfluxDB, they might define the retention policy as like 1 week. So they want to keep that data for a week, and then once it's past that date, it will be like the entire interval will be, the entire shard will be dropped from the database. And I have another blog that I can refer you to on this as well that I'll put in a second. But while that's happening, you want to be downsampling your data if you want to keep a snapshot of it, or keep like a little bit of an overview of it for later use. But essentially, like if that data were to be expired and then it gets dropped from the database, and if you haven't done any downsampling on it to kind of keep like an overview of it, then I don't believe that you can restore it. I believe that like once the data has expired and been deleted, I don't think you can get it back.
That's right.
Which is why we recommend downsampling, because you can at least keep an idea, you can keep a snapshot of what's been happening like in that specific week or in that specific time interval.
Just think about like what would potentially the shape of that graph look like of that data. And even with downsampling, you're going to be able to still maintain that shape, which is still going to give you an idea of, there was some kind of a pop in data that was unexpected, or a drop in data. You'll still be able to maintain that shape, because remember, what you're doing is you might be looking at data that's at a very precise level, and maybe nothing's really changing at that precision compared to something at a less precise level. So there's no reason to keep all that data if, at the millisecond level, if at the second level, everything looks the same, at least from a shape perspective.
Right. Yeah, exactly. Okay, I have to remember to find that blog after, but let me jump to this question. Okay, related to the question from Larry, I don't remember what his question was. Is there something for partitioning the data that would keep the partition data intact, but move it out to other storage? And then the downsampling could be applied to the live data. So I'm not exactly sure what you mean by partitioning the data. Like, do you mean in terms of dividing it into like certain time intervals, and then I'm a little confused on this question. I don't know. Does that sound familiar to you, Chris?
I guess we need to understand what the intent is. If your intent is to be able to use it for HA purposes, or if there's you're trying to just break it out so you can store it somewhere else, I guess we just need to understand a little bit more about the intent. I have I think I can guess, but let's get a little bit more detail on what you're doing.
Okay. All right, we'll come back to that question. Ooh, the downloads portal is down.
No, it looks like he had the wrong link. I think he follows up with that.
So this one says, I'm still evaluating the tick stack for data center scale operation metrics. I'm running through different loads. We have a multi-tenancy requirement. So we are trying to create a database per tenant. So far the tests are doing okay, but do I have other options to achieve the same thing? So I guess when you say other options, do you mean other like types of software, or
I think different approaches is what he's looking for.
or different approaches? Okay.
Yeah, so I think that one we should definitely put into the community. Let's go ahead and copy and paste that in there. So we actually do have a number of customers that are using it in a multi-tenant fashion, either for the purpose of maybe they're servicing a number of different groups within their organization, because they're kind of like the infrastructure team for a really large company, or it's actually a part of their service. So why don't we throw that in there, because there's a lot of different ways that we can probably, a lot of ideas that we have about how other people have done that.
Okay. The other question is, can Kapacitor be used to launch other tasks or programs on a given condition? So I think that's definitely possible. You can have user-defined functions in Kapacitor, and like similar to the way that like alerts are only triggered if a certain expression is evaluated to true or something. You should be able to, I believe, you should be able to do.
Yeah, that's exactly what what you would do.
Oh, okay. There's like a potential answer there. Okay, is there a way to set up retention and downsampling at database creation? Set and forget only once. I assume retention policy uses shards and therefore minimizes disk space. Can be expensive in the cloud. Okay, so when you set up a database, you do definitely have to set up a retention policy. That's for sure. However, with downsampling, that would be set up separately. I mean, you can do that at database creation, but it's not like in order to actually successfully set up a database in InfluxDB, there needs to be a retention policy that goes with it. And then in terms of downsampling, if you want to use InfluxDB, you can use the continuous queries to downsample, or so you would create a continuous query that would run on that database. Or you can use Kapacitor, as we spoke about today, to write a tick script or write a task to downsample that data as well. So it doesn't kind of just automatically get set up for you, but like if you wanted to set up a database and just didn't want to like specify the retention policy, it will get set to the default one, which is called autogen. Or you can edit that retention policy and specify your particular timeline for it. I'm not 100% sure I've answered your question there, but you can definitely set them up all together when you're starting out, if that's what you're asking. And then so InfluxDB does use shards and shard groups. That's for sure. So when a retention policy is set up, it does also specify the shard group duration, which like when your retention policy expires, that entire shard group will get deleted. So InfluxDB does not drop individual data points; it drops whole shards. Okay, how would I determine if Kapacitor is capable of performing a particular advanced analytic versus utilizing an external analytic engine? I think this would be easier to answer if I knew kind of like what context this is in or what exactly you're trying to determine. I don't know if you have anything to say about that, Chris.
No, I agree with you. The easy answer is it works with everything, but Yeah, we maybe just get a little bit more detail so we can be more accurate in our response. Why don't we go to the Q&A and just go through the answered questions real quick. So there's questions and answers there already.
Oh, okay. All right, so how does Kapacitor and InfluxDB handle data that is timestamped in the future? Some IoT devices may have an out-of-sync time clock that is running in the future by minutes or longer. Are there any issues with these timestamps? I don't think I've ever actually played around with data timestamped in the future. Have you, Chris? Hello? Okay, we might have just lost her. Yeah, so I'm actually not 100% sure about that. I would definitely recommend adding that to the community forum, because I'm sure that somebody has tried that out or been experimenting with that. So definitely, there would definitely be someone who could answer that question better than I can. This question, I believe we've already answered. Can we send a critical alert to PagerDuty, warn to Slack? For sure, you can do that. We've covered that. And then, is there any function in Kapacitor that assists in the task of data imputation due to data loss or time windows if data points were missing? And I believe that's no. And then the last question is it possible to query for a value from InfluxDB and use that in a Lambda query? Such as, for example, if the 5-minute average is greater than, and then put in a query statement from InfluxDB, and then if that evaluates to true, then alert. And yes, that is possible. You can query for values from InfluxDB in Kapacitor. Okay, are there any other? I think we've already answered this one.
We just have, yeah, there's a bunch in the open, and then there's, Bob came back with more details on the advanced analytics in the chat window.
Oh, okay, cool. Is there capability for the following time series analyses already built into the tick stack? So time series decomposition, for example, time series is seasonality plus trend plus noise, automatic anomaly detection, Granger style causality detection, which series appears to potentially cause others, and then potential to clustering time series based in similarities. So I don't think this is actually built in directly into the tick stack, but I think it's something that you could use the platform to be able to see this over time. I don't know if you have a better answer on that, Chris.
Yeah, so you're right. A lot of that stuff is going to be outside. This is where you would take have Kapacitor send it out to some machine learning tool. And so I just posted, one of our great partners, LoudML, has a really great tool. They have a really great free tier that you can play around with, where you can actually pull time series from InfluxDB and actually can do a couple of things that you're mentioning there. And you can actually bring it back into InfluxDB, because if you want to do a compare against the trained data with the raw data, you can do that, or you can put it into some other system. So I would take a look at that to be able to do that stuff. But within the tick stack, no, that's not. We don't have those capabilities within it on its own.
Okay. Is that everything, or?
So there's another question from Andreas. So potential answer to IoT question. Oh, he's answering it. Yes. InfluxDB writes a timestamp from its own instance when it receives data unless you specify the timestamp in the protocol. So if you have an IoT device in the future, then don't submit the timestamp along with your InfluxDB line protocol. Yeah, that you're absolutely right. So when applying a timestamp to a time series, it's either applied by receiving the timestamp in the data and via line protocol, or if there is no timestamp, then InfluxDB will automatically append that timestamp at the moment that it receives that data. So thank you, Andreas, for that.
Okay, there's also another question on retention policies. Is the retention policy based on the time that the data point was created or based on the timestamp of the data? It should be based on the timestamp of the data. Unless you didn't submit a timestamp, as Andreas had answered before, unless you didn't submit a timestamp when you sent the data point in, then InfluxDB already automatically creates a timestamp for that data point, which would simultaneously be the same as when the data was created. Is using Kapacitor with a batch task equivalent to using a continuous query? Because both of them are going to run a query on InfluxDB. This is related to downsampling. So technically, yes, a continuous query is running on InfluxDB, and like if you run a batch task, it's also running a query on InfluxDB. However, when you're running a continuous query, I can try to like put some examples maybe in the text, but you're usually going to also be applying some kind of function to it, some kind of computation to it, and that can be, that's pressure that could be relieved if you put it into a Kapacitor batch task. So for example, when we looked at the batch task in the batch tick script, we could see that we were running a batch task, we were querying the database, but all we were doing was saying like, select all of the data in this 5-minute time window that has the measurement CPU, or select everything from measurement CPU in this 5-minute time window that matches this tag. That's going to be a much simpler query to run on InfluxDB than having to not only run that query and then also do some functionality on it, like find the mean of it. Like if it's going to be more complex if you run it as a continuous query, because you're going to have that extra like transformation of the data. So if you run it as a batch task, you're relieving InfluxDB of that kind of extra functionality that it would normally have to do in a continuous query. And then the other thing I would say with continuous queries is that they can get really kind of confusing, because you usually have to run a lot of subqueries within those queries. So it can just like become a little bit harder to read if you're running like quite a number of them, or if you're doing a lot of computation on it. So it's sometimes easier to just put it into a Kapacitor batch task because it's a lot more readable, and it would be easier for other people to understand who are like coming in, who are new. I hope that answers your question. And I think that's everything. That's the same question. And this question is about the future timestamps. Okay. I
think we're good.
Did we cover everything?
Yeah, let me just double check. Okay.
If there's anything we didn't cover,
there's two more. So let me just. So it looks like Gresh, and I just unmuted you if you have a question. And
oh, here. What's the best way? There's another question.
So two of you who raised your hands, I've just unmuted you. If you want to ask your questions with your voice, we can just take a minute. I'll just wait for you for a minute.
There's also another question here from Stephen.
Go ahead. Go for it.
Okay, so what's the best way to drop data when time series exceeds the max value the system can hold? So generally, we don't want to get to this point, I don't think. That's the reason why retention policies are in place is so that you can, like, as the data becomes no longer relevant, you can have that data automatically get dropped from the database, so that you don't hit a point where you don't hit a point where you're overloading the system. That being said, you can manually delete data. That's possible as well. And then the commands, the specific commands for it, like you would have to drop data by shard, but you can manually drop shards. And that there's definitely commands in the documentation that talk more about manually having to remove data. But generally, we want to avoid this by having rate retention policies defined ahead of time, if possible.
So, Girish, did you get your question answered? I unmuted you if you want to.
Yeah.
Okay, great. All right, cool. Wow, a lot of great questions. We went way over time, and I apologize, but I think what we will do, we'll do two things. If we didn't answer your question, fully, we will take some of those and put them into the community site, so we can get some other points of view on those questions and answers. The other thing is we'll also take a look at some of these questions and make sure we add more examples in the training. The training's already long, but I think we can still add some stuff and make sure that we add some clarity. And I will do an edit of this video. I keep the Q&A section as well, so that'll be at the end. And I'll post it so you can take another listen to it. And if you do have other questions, please join us at our community site at community.influxdata.com. And there's a bunch of us sitting there answering your questions. Otherwise, join us next week for the training that we have next week. I think, Margot, you're on it again.
Yes,
and we'll be going over optimizing your tick stack. So you're free to bring your capacitor questions there as well. And if you have other needs for trainings, just shoot me a line. You guys all have my email. And we look forward to helping you guys build some spectacular products. All right, thanks everybody, and enjoy playing with tick stack.
Thank you.